Hello fellow Econauts and welcome back to our show. I'm here with my brother Ben, the Rocketman, and today we are talking about chemical propulsion. Hey Ben, how are you?
Hey Simon, how's it going? Hey fellow Econauts. Yeah, today we want to talk about chemical propulsion. Specifically, we have mentioned the rocket equation a few times in the past, so I think it's time that we explain a little bit how rockets start and what chemical propulsion is.
Perhaps you can let us know what is chemical propulsion.
I mean, the name gives it away. We have a chemical reaction. So usually we burn something, a mixed fuel, which gets oxidized and then oxidizes. And in that process is very exothermic, means it releases energy. Usually a gas expands. That expanded gas is guided through a nozzle and hence generates thrust. It's a bit similar like a combustion engine where, we mix something into a small chamber which is sort of pushed with a small piston, and then once it's igniting, the gas expands and pushes the piston down, and hence we get the movement of an engine. But now the difference now is we are releasing that gas through a nozzle, and that pushes us forward. The systems range really from all the matters, state of matters we have. So we can have gaseous uh, propellant systems where the gas, the fuel, which is the gas which we're igniting, and the oxygen are in a liquid, in a gaseous form. Obviously, you're then constrained how much you can take with you. Then we have liquid propulsion systems where the fuel and also the oxygen are liquefied, therefore more dense, and you can carry more of it. And we have solid rockets. The solid rockets often have the advantage that the oxidizer is baked into the actual fuel, so we don't need to carry an extra oxygen tank. Correct. The shuttle missions and also the SLS, the first stage is actually, so the two rockets on the side, they are solid rockets, and they bring the first stage, or the first they bring the whole spacecraft to a certain height and then get departed, and that's when then the liquid rocket starts. So you could say that that multi-stage approach is a hybrid rocket system. Yes, so hydrogen is mainly used by NASA back like from Apollo started to also the shuttle missions and now SLS. Hydrogen has per mass the densest energy. However, it has the disadvantage of, to make it, to transport it, to store it, and also because it's so undense, hydrogen is very light. The rockets have to be much larger compared to other liquid fuels. But yeah, so hydrogen and oxygen is still the go-to rocket fuel. We have only one other, or not one other, but another alternative, which is not methane, would be hydrogen, which is very toxic. But the advantage with hydrogen is you don't need an oxidizer. So that's a so-called monopropellant system where you only have to carry the fuel, similar to a solid state rocket. And yeah, but as I mentioned, there are other liquids such as methane used to propel the rocket. Obviously, a rocket, you cannot just exchange the fuel, right? So you can't just put hydrogen and oxygen in an engine in a rocket nozzle that is built for methane or hydrogen. So you can't just mix that. Again, trying to make the analogy, although it's not quite the same, but think of a diesel engine and a petrol engine. If you fill diesel in the petrol engine, that will not work anymore, right? So similar to that as well, the whole physics and the geometry of the nozzle is optimized and built for a certain expansion, which is generated by that specific fuel it's built for.
So I think SpaceX is using methane and oxygen instead of hydrogen. Maybe you can let us know a little bit about that.
Methane is already can be liquefied very easily compared to hydrogen. So you can make it even denser and therefore pack more liquid with you for the rocket. It is also from the volume less large, so therefore you can build the whole rocket smaller, or if you have a large rocket like Starship, you can take more fuel with you. It is easier to transport, it is easier to get, and so on. So methane makes a lot of sense.
Well, fellow Econauts, that's already it for today. I hope you liked this episode. If you did, don't forget to leave a like and subscribe if you haven't already.
And don't forget to hit the notification bell so that you always get informed when a new episode is up. And we would also like to see your comments under our shows. So we will respond to everything in due time and also take recommendations.
All right. I think that's it. We wrap it up, and I hope you will have a good day, and I see you next time. Bye-bye.
Bye.